Say, I like your outfit there.
Today we're going to learn about helium, where it came from, what it can be used for, and what it is used for. Helium is the second element on the periodic table. Helium has an atomic number of 2 and an atomic weight of 4.002. It is considered a non-metal and it is considered a noble gas. Helium was discovered in 1868 by William Ramsay and Lord Rayleigh using spectrophotometry, discovering its line spectra during a solar eclipse. Helium is the second most abundant substance in the universe and was created during the Big Bang. Helium is formed by a process called nuclear fusion. In this case, we have a deuterium and a tritium combining at high speed and high temperature to form a helium nucleus and a neutron. Here's a balanced equation of another way that helium is formed. After hydrogen and helium were formed, inside of stars, carbon was formed and all the other elements of the periodic table. Inside stars, helium is pressed into carbon. Here's the balanced equation of 3 heliums being pressed into 1 carbon. Here we see that during this reaction, energy is also produced. Nuclear fusion can be used as a clean energy source using a deuterium and a helium-3 pressed together at high speed and temperature to form a helium and a proton. This balanced equation shows helium-3 and hydrogen deuterium forming helium and a hydrogen. On Earth, helium is fairly rare. It's only found in a few spots. The main spot helium is found is in the central United States, with helium-3 being even more rare, only produced from nuclear decay and nuclear reactions. Here's an example of one form of nuclear decay. In this balanced equation of nuclear decay, we can see that uranium decays into thorium and a helium nucleus. Here's a further breakdown to see exactly what's happening. These produce a relatively small amount of helium, and someday we may need to look to the moon as a resource for helium, and mining may be a viable option. Helium is in its gas state most of the time, liquefying even lower than hydrogen at about 5 degrees above absolute zero. Here's a demonstration of a unique feature of helium. Here helium is being cooled even below 5 degrees above absolute zero. You can see the rapid evaporation, but around 2 degrees above absolute zero, it transforms into what's called a superfluid, where it has no viscosity. You can see here that once turned into a superfluid, it somehow leaks through the container that it was previously being held by. This lack of viscosity is also seen here in a frictionless fountain that can run forever. Another interesting feature of supercold helium is the fact that it somehow defies gravity, shown here, climbing the edges of a glass. These amazing features of supercold helium led one of our great minds, Albert Einstein, to theorize about a new state of matter called Bose-Einstein condensate. Helium's properties while cold make it an ideal coolant for MRI machines, its most commercial use. But helium has other commercial uses as well. One of these uses is being used in the blimp. We can see here that a blimp filled with helium is able to float. That's because helium is lighter than air. Which leads me to one of helium's most well-known uses, its recreational use. This recreational use is used to change people's voices from a regular voice into a high-pitched voice. To help me explain this, here's Adam Savage from Discovery Channel's Mythbusters.
I promise to show you something really cool as long as you promise not to try it at home, okay? Okay. Now, everyone wants to know why my voice sounds higher when I inhale helium.
The simple fact is that helium is 6 times less dense than air, which means sound waves travel through it much faster, which makes my voice sound much higher. Now, the same effect can be achieved in reverse if I inhale something like
sulfur hexafluoride, which is 6 times denser than air. I inhale some of that, and my voice gets really low, although somehow I'm still funny. It's scientific!
Helium's lighter than air properties enable it to do some amazing things that even astounded NASA. Here we can see a person filling a helium balloon. Attached to it is a camera. It was able to achieve pictures that have been associated with multi-million-dollar projects before. This was done with a digital camera and a helium balloon. While all the reactions up to now have been nuclear reactions, line spectra from the sun indicates that helium also has a chemical reaction. While not on Earth, it does happen in stars. This reaction is where a helium and a hydrogen go together to form a helium hydride. Here's the MSDS sheet for helium. As you can see, no expected harm is to come from contact or exposure. We have seen where helium has come from, some of its unique properties, and its potential for future use, as well as its commercial and recreational uses today. I hope you learned something and enjoy helium as much as I do.